Hello friends, welcome once again to my channel Ojuk's Online Math Class. In this video, I would like to teach you how to derive quadratic formula using completing square method. As you can see on the board, we have the general form of quadratic equation, which is ax squared plus bx plus c equals to 0. As you all know, the quadratic equation is a second degree polynomial equation. So it has the highest power of x as 2. So we want to use this general form of quadratic equation to derive quadratic formula using completing square method. Now to do this, it is very simple. As you can see, we have a, b, and c in quadratic equation as a constant. First step we have to take here is to transfer the constant c to the other side of the equation. That is first step to take in deriving quadratic formula using completing square method. Now when we transfer the constant c to the other side of the equation, automatically we are all conversant with the rule of transferring constant or values to the other side of the equations. Now when we do that, we'll have ax squared plus bx. We are transferring the constant c to the other side of the equation, and when we do that, we have to be very mindful of the signs. When we do that, we'll have plus c crossing the equality sign, it changes to minus c. So we'll have it as what? Minus c. Let's continue. The second step is this. Make the coefficient of x squared a unit. When we talk of making something a unit, it simply means make it to be equals to 1. So how do we make the coefficient of x squared a unit? By dividing through the whole equation, these three equations, all this equation by the coefficient of x squared. When we do that, so we'll divide the whole equation by the coefficient of x squared, which is a. Divide through by a. And when we do that, automatically a will cancel out a. Coefficient of x squared is now a unit, is equals to 1, as you can observe here. So we have in return x squared plus bx over a equals to minus c over a. We have taken the second step. Then the third step is this. Multiply 1 over 2 to the coefficient of x, then square the result. I repeat, multiply 1 over 2 to the coefficient of x, and we all know that the coefficient of x in this equation is b over a. So b over a times 1 over 2, then our result will have to square. When we do this, we have it b times 1 is b over a times 2, we're having 2a, all raised to power 2, as you can see. Then we have done this. We have multiplied 1 over 2 to the coefficient of x, then we have squared the result. The next step is what? Add the result to the both sides of the equation. Automatically we have the left hand side of the equation and as well the right hand side of the equation. So we are going to add this to the both sides of the equation, then we'll solve. When we do that, we have x squared plus b over ax equals to, okay, we're adding this to the both sides of the equation, then plus b over 2a all squared equals to minus c over a plus b over 2a all squared. Okay, we have added the result to the both sides of the equation. What next? Now, when you observe the left hand side of this equation, you strongly concur that we have two perfect squares there. So what we have to do next is what? Collect the perfect squares. When we do that, we have this and this as the two perfect squares here in question. Then we have to collect the two perfect squares. When we do that, we have it that x squared plus, then this is the perfect square as well, b over 2a all squared equals to minus c over a plus b over 2a all squared. As you can see, if we keep on solving further, if we beckon on the left hand side of this equation, according to law of indices, both of them are having the same power. What we have to do is what? I can then collect both of them, x plus b over 2a, and raise them to their common power, which is raised to power 2, equals to, we have minus c over a plus, according to law of indices, power law. This implies b over a is raised to power 2. It implies that all the terms inside this bracket are having this common power. If they're having this common power 2, we'll have it that b is raised to power 2 over, then 2 is raised to power 2, then a is raised to power 2. So we'll have a raised to power 2. If we were to solve for that, we'll have it that x plus b over 2a all squared is equals to minus c over a plus b squared over 2 raised to power 2 is 4, then a raised to power 2 is a squared. If you are to solve for that, let's continue. Now, if you observe the right hand side, we'll have two separate fractions. I want to make these two separate fractions to be a single fraction or to be a conjoint fraction. I'll automatically solve for their LCM. When I solve for the LCM of these two denominators, automatically we all know that the LCM of a and 4a squared is 4a squared. Now we'll start to divide. A into 4a squared, we're having 4a. Then 4a times minus c is minus 4ac. Plus 4a squared into 4a squared is 1. Then 1 times b squared is automatically b squared. So I have in return that x plus b all over 2a all raised to power 2 is equals to this. Now, if you observe this right hand side of the equation, I have minus 4ac plus b squared. Automatically, you know in mathematics that addition is commutative. What do I mean by addition is commutative? If we have 4 plus 2, is same thing as saying 2 plus 4. Okay, let's observe. 4 plus 2 is 6. Then 2 plus 4 is also what? 6. So if we can, if we have the knowledge of commutativity of addition, we can also express minus 4ac plus b squared as starting b squared first. B squared minus 4ac, nothing has changed. They are the same thing. So if we know the principle of commutativity, I can equally have this x plus b over 2a all squared is equals to, starting b first, I have b squared minus 4ac all over 4a squared. I have this. Both of them are the same. Nothing has changed. Now, I want to remove this square. Automatically, to remove this square, I have to find the square root of both sides of the equation. So when I find the square root of both sides of the equation, automatically square will cancel that square root. So in return, I'm having just x plus b over 2a equals to square root of b squared minus 4ac over square root of 4a squared. I splitted the square root because of what? They are having what? The same root. So in this case now, if I am to solve further, I will have it that x plus b over 2a is equals to square root of b squared minus 4ac all over, okay, square root of 4 we have 2, square root of a squared, we are having just a. Okay, what next? Remember, I want to make x the subject of formula. I want to solve for x. Now, since this is a quadratic equation, immediately I introduce my square root because of what? The root of quadratic equation is always 2. It's a second degree polynomial. So when I do that, I will equally introduce my plus and minus as usual. Plus and what? Minus. Now in this case now, I want to make x the subject of formula. Now, how do I solve this? I will have to transfer plus b over 2a to the other side of the equation. When I do that, I will have that x is equals to, then transferring this to the other side of the equation, I have minus b over 2a plus or minus square root of b squared minus 4ac over 2a. As you can observe here, I also have two fractions here. I want to make them a conjoint fraction, that is a single fraction. I will equally solve for their LCM. When I do that, I'll have it that x is equals to, then LCM of 2a and 2a is automatically 2a. I'll have it as 2a. 2a into 2a will give me 1. 1 times minus b, I'll have minus b. Then equally, I will introduce my plus or minus. Then 2a into 2a is 1. 1 times square root of b squared minus 4ac, I'll have square root of b squared minus 4ac. So as you can see, I have succeeded in getting the value of x. And as you can see, the value of x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So this is actually the quadratic formula that we'll do hereof. So we can use this quadratic formula to solve every quadratic equation. We can use this quadratic formula to solve any kind of what? Quadratic equation. Thank you for watching. I guess you enjoyed this video. Do not forget to subscribe to my YouTube channel so as to get notified whenever I drop a new video. Thank you and remain blessed.